Welcome back, students. This is the session number 12 from the chapter of laws of motion, and the topic is equilibrium of concurrent forces. So this is a very small session, and I will be discussing only the main points regarding this topic. So first point is, if a number of forces act at a point, then they are called the concurrent forces. Second point is, for the equilibrium of a body under the action of concurrent forces, the vector sum of all the forces on the body must be equal to 0. That is, for any body to be in a state of equilibrium, the vector sum of all the forces which are acting on that body should be equal to 0. So in that equilibrium condition, the body will be we can say that this sum of all the forces, that is, we can write this as sum of the forces. If I am just taking the Cartesian frame of reference, let us say x, y and z axis. This is the z axis, this is the x axis, and this is the y axis. So this definition can also be written as it is summation of you can say the vector sum of all the forces in the x direction, that is summation of x, that is fx, plus the vector sum of all the forces, say in the y direction, plus the vector sum of all the forces in the z direction. This will be equal to 0. So this second definition can also be interpreted in this way, that is the vector sum of all the forces in the x direction plus the vector sum of all the forces in the y direction plus the vector sum of all the forces in the z direction. If it is equal to 0, then we can say that that body is in a state of equilibrium. Now, with regards to this topic, I just wanted to discuss about the Lami's theorem. So the Lami's theorem states that if a body is subjected to three concurrent forces, so let us say this is P, let us say this is Q, and this is R. Now, so if a body is subjected to three concurrent forces, is subjected to three concurrent forces, and it is in a state of equilibrium, then P upon, let us say this angle is alpha, this angle is beta, and this angle is gamma. So then the magnitude of this force P divided by the angle divided by this sine gamma, that is the angle which is just opposite this this force P. So this is the force P which is exerted on this point of this on an object. This is the force Q and this is the force R. Now this alpha is the angle which is subtended by these two forces, that is Q and P. Beta is the force, beta is the angle which is subtended by this force P and R, and gamma is the angle which is subtended by the force Q and R. So in this case, as per the Lami's theorem, P divided by sine gamma will be equal to Q divided by sine beta. and r upon sine alpha. So in this case, what we have to do is we have to take the angle, that is, for example, for the force P, we have to take the angle which is just opposite this force. That is the angle which is subtended by the other two forces. That is in the P divided by the angle subtended by the other two forces. That is so in this case it will be equal to sine gamma, means gamma is the angle which is subtended by Q and R. Similarly, Q divided by the angle subtended by the other two forces, so this will be equal to sine beta. Then divide is equal to R divided by the angle subtended by the other two forces, that is Q and P. So this will be equal to sine alpha. So this is this is called the Lami's theorem, and this formula, that is P upon sine gamma is equal to Q upon sine beta is equal to R upon sine alpha with respect to this diagram, or with respect to this example. So this formula is can be used in a number of questions, and it is used in a number of questions. So and this is a very, very important relation. So so in this session I just wanted to discuss about this Lami's theorem, because I just wanted to tell you about this formula. So thank you very much for joining this session, and in the next session we will be coming up with some numerical problems. So till then, have a nice day. Bye.